All right, so listen, now that you've learned the relative terms and how to apply them, I want to teach you the very beginnings of using trigonometry to do something that we call solving um, triangles. So the objective is to be able to solve right triangles using trigonometry. And before we get started, let's figure out what does it mean to solve a right triangle. We've heard of solving equations before, but to solve a triangle means, especially a right triangle, solving a right triangle is simply the mathematical way of saying find the missing side or angle, or find all the missing sides and angles. It means find all the values, the lengths of the sides and the degree measures of the angles. So before we start, we now know solving right triangles means we're going to be finding the missing sides and angles. And using trig, well, here goes. The first thing I always teach my kids is how to say the words. Now you notice on the calculator you've seen these three words. And today I'm going to teach you what they mean. First of all, we know sin is not sin. The real way of saying it is sine. Cos, you don't say cos, it's cosine. And tan is not tan, it's actually tangent. And we're going to define what all three of those mean. And we are going to define sine, cosine, and tangent as ratios, as fractions, because that's all they are. If anyone ever asks you what is sine, cosine, and tangent, you could just say they're ratios, they're fractions. And this is how it goes. And this is what it goes. I mean, how it goes. And as we begin, I'm going to write something down, and I'm going to teach you how to say it and what it means and how to apply it. I just want to start by saying you're going to see something like this, defining the sine as a ratio. It means the sine of theta equals the ratio of the opposite side to the hypotenuse. And I'll show you what it means, but it means you're going to take a ratio as a fraction. So sine means take the length of the opposite side over the hypotenuse. You'll see very shortly what I mean. The cosine of your reference angle theta is defined as the adjacent side, the length of the adjacent side, over the length of the hypotenuse. That's a ratio, it's a fraction. And finally, the tangent of your reference angle theta is the ratio of the opposite side to the adjacent side of your reference angle. So if you're wondering, well, what does that mean? Okay, it means this. Let's teach this by way of an example. So I'll put example 1. And this is a lot of new information for you. But if I were to teach this using example 1, that means, guess what? I'm only dealing with right triangles, and I might start off with a right triangle that looks like this. And in the right triangle, the right angle, again, can never, ever, ever be your reference angle theta. Never. This just tells you that you have a right angle here, which means that this triangle is a right triangle, which means you could use trig in the first place. So supposing I call the only angle that could be theta is one of the acute angles. So supposing I call this my theta. That's my reference angle. And the reason we're using reference angles is because opposite, adjacent, those are all relative terms. And so what if I told you I have a triangle where this hypotenuse is 5 units long, the length of this side is 3 units long, and the length of this side is 4 units long. And supposing I said, I want you to find the sine of theta as a ratio. Supposing I said, I wanted you to find the cosine of theta as a ratio, and then the tangent of theta. Well, by definition, this is what the sine, cosine, and tangent mean? So this is just something you're going to have to memorize. Well, actually, it's going to be on the reference sheet, so they give this to you in case you forget. But if you ask for the sine of theta, if they say, what's the sine of theta? First of all, the first thing you got to do is identify where the theta is, your reference angle is, and guess what? There's theta. So all of those reference terms, all those relative terms are relative or with respect to this angle because that's my theta. So if we look at sine theta and we say, oh, the sine of theta, the sine of our reference angle, is nothing more than the opposite side of theta over the hypotenuse. And you could even write that down again just to solidify your knowledge of what sine is. So the sine of theta is the opposite side of theta over the hypotenuse. So if you just fill those in, you find out that if this is theta, we learned that to find the opposite side, you just imagine a line coming out of the center of theta, and it always stops at the opposite side. So the opposite side of theta would be 3. And the hypotenuse is just the longest side. Now that's 3, that's 4, and that's 5. So obviously the hypotenuse is 5. Now if you want to figure out what is a cosine, all the cosine of a reference angle means, it means the ratio of the adjacent side to the hypotenuse. So that's easy because we know that if this is our reference angle, then the side opposite that comes clear across, that's the opposite side. We know this is the hypotenuse because it's the longest side, so that leaves this side to be the adjacent side. And by our definition, the adjacent side is just that leg that is touching theta. So since cosine of theta is the adjacent over the hypotenuse, well, what's the adjacent? It's right there. It's 4. What's the hypotenuse? Again, it's 5. And finally, the tangent, which we defined as the ratio of the opposite to the adjacent. So we could even write that down to help us remember. Opposite to the adjacent. So let's actually fill it in with numbers. What is the opposite side? Again, opposite of theta is 3. Adjacent to theta is 4, because that's the hypotenuse. And you have just found the sine, cosine, and tangent of a given reference angle. So one thing I would do is maybe put some steps for this when you're trying to find sine, cosine, and tangent. The steps might be like really quickly. What's the first thing I did? I will identify and label my reference angle theta. The second thing was, I would probably label the relative terms. In other words, I would label which side is the opposite side, which side is the adjacent side, and which side is the hypotenuse, based on which angle is theta. Then I might write the 3 trig identities, and then I would substitute. Let me give you an example of what I'm talking about. Let's zoom out. Here's an example. Supposing I said, here's an example. I might say, find the sine of angle Z. I might think, find the cosine of angle Z, and maybe find the tangent of angle Z. And supposing my triangle looks like this. Here's my right triangle, and supposing I call this triangle X, Y, z. So that's my triangle, x, y, z. And supposing I said this side was 30, this side was, I don't know, 16, and supposing this was 34. And if I said I want you to find the sine of z, the cosine of z, and the tangent of z, let's look at those steps. Let's identify and label theta. Theta is the reference angle. So if they're asking you to find the sine of z and the cosine of z and the tangent of z, guess what's your reference angle? Well, we're talking about angle z. It's all with respect to angle z. So that is my theta. That's my reference angle. And I wanted to make sure you know that that's the reference angle. It's the angle that we're looking for the sine, cosine, and tangent of. And the theta, the reference angle, is what gives meaning to opposite, adjacent, and hypotenuse. Well, the next step says, once you identify and label what theta is, which is this, based on the fact that we want to find the sine, cosine, and tangent of z, angle z, then we label that theta. Then we have to, you don't have to, but this is what I do. I will just write down which side is the opposite, adjacent, and hypotenuse. Right away, the longest side, because you could tell, look at the numbers. That's the biggest number. This side is the hypotenuse. And if you think about that imaginary line coming straight out of the center of the reference angle, that always touches the opposite side. So guess what? Side yx is the opposite side. And the leg that touches theta is called the what? And the kids would say adjacent side. Because that's the opposite, that's the hypotenuse, that's the adjacent. So once you label all that, and eventually you'll not have to do any of that because it'll just come, it'll be like second nature. Then when we want to find our answer, we write, I'm saying for instructional purposes and for beginners, write the three trig identities. In other words, we know the sine of theta equals opposite over hypotenuse. We know the cosine of theta equals the adjacent side length over the hypotenuse, because we're defining the three trig as ratios. The three trig identities are written in terms of ratios, and the ratio for tangent of theta is the opposite over the adjacent. So to get our answers, we now know, since our reference angle is z, then the sine of z equals, based on this, it's the opposite over hypotenuse. So we look at our triangle and we say, which one's the opposite? Is it the 30, the 16, or the 34? What is the opposite? Well, we look right here and we say the opposite of z, which is our theta, is 16. And the hypotenuse, which is that long side, is what? 34. Then we could do the cosine. The cosine of remember, the cosine of any reference angle is the adjacent side of that angle over the hypotenuse. So the cosine of z, being the reference angle, is the adjacent. By this definition, adjacent over hypotenuse. Which side is the adjacent? Well, that's the hypotenuse, that's the opposite, so that's the adjacent. So we put the adjacent side over the hypotenuse, and the hypotenuse is 34. And that's the cosine of z. Finally, the tangent of angle z, we know is the opposite side of z, which is 16, over the adjacent side of z, which is 30. And we just found the sine, cosine, and tangent of our reference angle z, and that's correct, and that's correct. Oh, you're worried about reducing? That's fine, you can reduce. But right now, it's not an arithmetic class, it's just we're trying to figure out these ratios. And that is how you find the sine, cosine, and tangent of a reference angle. And if you have questions, let me know. That is the short, and the long and the short is 7.2. Just finding those ratios. All right, thank you so much. And let me turn this off here.